we have discussed the introduction to benzene and its derivatives. In this session, we are going to cover a topic on nomenclature of derivatives of benzene. Can you tell me, can I replace the term derivatives of benzene with anything else? You got it right. The derivatives of benzene can be replaced with the term benzenoids. That is a short term to write derivatives of benzene. Now in this lesson, we have to study nomenclature. Nomenclature means giving names. Like we as human, we were assigned a name by our parents or maybe our grandparents or any of the other relatives. So name is very important because by this name itself, everyone around you refers to you. So whenever there is a chemical compound and people want to talk about the compound, then the compound must have a name. So there is importance of having the name. Now, the chemical compounds are not given the name like we humans are given. We cannot call the compounds as Cuckoo, Chotu, Monu, Babu with any of these terms. Because this will create confusion. Because people are going to name the compound as per their likeliness. Suppose somebody wants to give benzene a name Monu. He thinks that Monu is his favorite name. So he should call this particular structure with the name Monu. And somebody else would like some other name for it. Let's say the word is Rocky. So this will do nothing but create confusion. So the responsibility of naming chemical compounds is taken care by a body with the name IUPAC. I'm sure you have heard this name IUPAC. Let us first see what this IUPAC is. IUPAC was an abbreviation. That means there is a full form to it. IUPAC stands for International Union of Pure and Applied Chemistry. This is the full form of IUPAC. It is actually a federation of chemists. That means it's an international body and it is an organization which represents the whole scientific community. This is not one person which is directing to give us the rules that has to be followed, but this is actually a group of chemists. Yes, there is the headquarter for this body and it is in North Carolina, United States. There is a headquarter for it. It is established way back in 1919. Must know these things. It will boost your confidence and maybe sometimes question can be asked that what do you know about IUPAC? You know the IUPAC naming but you do not know about IUPAC. That can be a bad thing. So try to get familiar with this IUPAC as an organization. So established way back in 1919, what a easy number to remember, has its headquarters in North Carolina, United States, and it is the body which has given out the rules for the nomenclature. So let's see what this is. It has given out the rules which has to be followed if we want to name any chemical compound. So benzene and its derivatives are chemical compounds, isn't it? So even when we have to name benzene derivatives, we have to follow the rules which are given by IUPAC. So we are going to discuss the classification, or you can also call them the examples. And while discussing this classification or examples, we will become familiar how to assign names as per the IUPAC rules to benzene and its derivatives. So let us first see the case 1 where the benzene is going to be mono-substituted. Mono-substituted means we have the benzene and it is singly substituted. Singly substituted means there is only one group that would be present on benzene. Like you consider these examples. Here there is only one group, which is bromo group. This is another one. There is one group which is nitro group. And here this is another one. It's a long chain in itself, but if you will see, it is attached to benzene with one site only. Through one carbon site only, this whole group is attached. So it is also considered as mono-substituted benzene. We will see what di-substituted and poly-substituted benzene examples are, but right now consider these three examples which are mono-substituted benzenes. So in the case number 1, there is subcase A. We can sometime name mono-substituted benzenes by prefixing the word of the group before the word of benzene. So this is called prefixing. When you put something before the actual name, this term is called prefix. Contrast to this, there is the term which is added after the word. That term is called suffix. So right now we are considering a subcase where prefix are being utilized to name the benzene derivatives. Suppose bromo is attached to benzene, then this can be called bromobenzene. And if nitro group is attached to benzene, this can be called nitrobenzene. And this whole group is isopropyl group. As per the IUPAC nomenclature, the chain of 3 carbons is called propyl. Iso word is added because the site of attachment is the central carbon. Otherwise, if it was attached through this carbon, this would be called N-propyl benzene. Right now the site of attachment is through the carbon in between. Then this is called isopropyl group, and collectively it is called isopropyl benzene. So I hope you have understood the subcase number A. Let us take subcase number B, where the name of the group is going to be used as suffix. It is contrary to the previous case. Previously we have kept things as prefix. In this case we are going to keep the substituent name as suffix. This is not decided by anyone that which groups can be kept as suffix and which can be kept as prefix. It is as per the usage itself. So the examples that you are going to study, you can remember that you do not usually call it sulfonyl benzene, you call it benzene sulfonic acid. So just simply try to inculcate these names in your daily usage, that you always call it benzene diazonium chloride and not as diazonium chloride benzene. So it is just giving you case studies that sometimes the name of this substituent is used as suffix. So the examples are, whenever the benzene is attached with 2 nitrogens followed by a halide like chlorine, you can name it as benzene diazonium chloride. Diazonium because there are 2 nitrogens and the aza word is used to refer nitrogen. So diaza because 2 nitrogens, so diazo. Onium because it has positive charge and Cl has negative charge. So azonium because there is positive charge here. So onium word is referring to positive charge over nitrogen. And chloride is referring to Cl negative. Cl is called chlorine. Chloride is because it is Cl negative. So I hope you are getting how to name the benzene derivatives. The other example can be benzene sulfonic acid. In this case, the SO3H group is attached to benzene. So this substituent is given the name sulfonic acid, and the sulfonic acid is being used as a suffix to the word benzene. So collectively the name is benzene sulfonic acid. So these were the subcase number 2. Let us see subcase number 3 for monosubstituted benzene itself. From the previous two cases, we are only discussing how to name monosubstituted benzenes. So third case also belongs to monosubstituted benzenes, and the thing is that sometimes benzene derivatives are assigned unique names. Unique names means that actually have to call with some other name, but sometime a unique name is assigned. Like you can call this particular benzene as aminobenzene, but instead of calling it as aminobenzene, you call it aniline. So aniline is a kind of unique name. So all these 5 examples are the examples of assigning unique names to benzene derivatives. Like methoxy group on benzene is called anisole, methyl group on benzene is called toluene, COOH group on benzene is called benzoic acid, and hydroxy on benzene is called phenol. So this was the subcase number 3. All 3 cases were belonging to how you name monosubstituted benzenes. Let us move to case number 2. Here we have to assign names to di-substituted benzenes. Di-substituted benzenes mean the benzene is going to be substituted with 2 groups. Like there are 2 groups over here. There are 2 groups over here. So these are di-substituted benzenes. Now the first subcase is under the di-substituted category. There are one subcase. Sub means under this category there is a case. So it is called subcase. So the subcase is, suppose both of these groups are same. It means the benzene is di-substituted, that is correct, but the 2 groups are same. Like there are 2 bromine groups on benzene. So you can call it dibromobenzene. When there was only one bromine, it was simply called bromobenzene, and when there are 2 groups, it can be called dibromobenzene, but you have to specify the relationship between these 2 groups, because the other bromine can be adjacent to the previous bromine, or it can be on the 3rd position, or it can be on the 4th position. So such possibilities are there. So in order to accurately refer to the particular compound, we have to specify that which particular dibromobenzene it is. So either we can write it 1,2 dash dibromobenzene, so that will signify that there is 1,2 relationship between the 2 bromo groups. This 1,2 di relation is also called the ortho relation. Being next to each other, this relationship between the groups is called the ortho relationship. There is a word for it, ortho, and it is abbreviated as small o, so it can be referred as O dash dibromobenzene. Let's take the next example. Here we have 2 nitro groups. So the relationship between the 2 nitro groups is 1,3. Isn't it? So there is a name for it. We can write dinitrobenzene, that is fine, but we have to specify the relationship between the 2 groups. So the relationship is 1,3. Otherwise it can be abbreviated as M dash, because 1,3 is referred by the term meta. So M for meta. Okay. Suppose there are 2 groups which are similar, and the relationship between the 2 groups is 1,4. 1, 2, 3, 4. One is on 1st position and the other one is on 4th position. So this can be named as dichlorobenzene, and for the relationship part, the alphabet P can be used because the P alphabet signifies the 1, 4 position. It has a word for it. The word is para, and para can be abbreviated as P dash. I hope you have got how to name di-substituted benzenes when the two groups are similar. Let us take the next example. Here there are going to be two groups. So suppose one group is COOH and the other group is nitro. So both the groups are not similar. So that means we are discussing the subcase where the two groups are not similar, they are different. So in this case, what we can do, we can consider one group as the main group. He is the main hero. Suppose there are multiple actors in a film, so maybe the role of one actor is more dominant, so he can be called the main actor. Like Jethalal is the main actor of Tarak Mehta Ka Ulta Chashma. So likewise, out of the two groups, we can call one of the group as the main group. In this case, the COOH group is called the main group. So COH on benzene is called what? You already know this thing. This is called benzoic acid. So when this is called benzoic acid and there is nitro group on the fourth position as compared to the COH group, the molecule can be named as 4-nitrobenzoic acid. Got it? It's easy. The concept is simple, that you have to assign one functional group as the main group so that you can give a unique name to the benzene and simply write the other group as the prefix and simply specify its position. So that is all is there while naming such compounds. Let's take another example. Benzene with OH can be called phenol and benzene with NH2 can be called, can you recall it? It is called aniline. So either we can keep phenol as the main functional group, otherwise we can also do it with amino, so it becomes aniline. It is up to us, whatever way we want to name it like, we can. There is no hard and fast rule for this. There are no strict rules for this. Either you can call it 3-hydroxyaniline, otherwise you can call it 3-aminophenol. So both of these words would be correct. They would refer to the same compound. There would be no confusion of any kind. So that is why both of these names would be accepted. Let us go to the third example. Here, benzene is attached with two groups. One group is cyano group, that is CN, and the other group is COCS3. There is 3 missing from the back. Write it by your own. So this is COCS3. This group is nothing but the acetyl group. There is a common abbreviation for CS3CO group, that is acetyl group. So in this case, we are going to name benzene with cyano as benzonitrile. When we were discussing benzene and its derivatives, there was a case where cyano on benzene is called benzonitrile. So we are going to keep this as the main functional group, and as per the cyano group, on the second position is the acetyl group. So we can name this molecule as 2-acetyl benzonitrile. The I should not be there. I is wrongly written here. Okay, so this can be called 2-acetyl benzonitrile. NITRILE. There are spelling mistakes here, but I'm sure that you will be able to correct it, because you do not have to memorize things, you actually have to understand the things. Do not limit yourself up to understanding only. You have to actually utilize what you are learning. We will discuss about someday when we find time. So let us come back to the last subcase of di-substituted benzenes. We have discussed when the two groups are similar, then how you are going to name the compounds. When we have discussed how the two different groups are there, how you are going to name the compounds, let us take the example when none of the groups can be considered as the main functional group. Previously, we were able to assign one of the functional group as the main functional group. That is why we were able to name the compounds. Suppose none of the group qualifies, or you can say outweighs the other group. Both the actors are equal. Ajay Devgan and Tushar Kapoor, let's say both of them has played an equal role in Golmaal. Then how can you assign one of the actor as the main actor? It is not possible. So in this case, what you do, you consider both of the groups as the prefix and you simply have to sort their names alphabetically. This means that you are going to write bromochlorobenzene. That is fine because both of these groups are going to be used as prefix. But you simply have to write bromo first and chloro later because B comes earlier in the alphabet series and C comes later. And you also have to assign the number 1, 2, 3. This is based on the atomic number of the atoms. Bromine is assigned first group position because bromine has higher atomic number as compared to chlorine. So 1 bromo, 3 chloro, benzene. Bromo is being written earlier because B comes earlier in the alphabet series. Alphabet series means A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. Okay. Let's take the another example. Here we have fluoro and nitro group on benzene and we have to name it. So both of these groups are going to be used as prefix. Fluoro for fluorine, nitro for nitro group, and benzene later on. The first number is for fluorine because it has higher atomic number. Second for nitro, as F comes earlier and N comes later on, so fluoro is coming earlier and nitro is coming later. Let us take the third example. In this case, there is a mistake. The mistake is this: the ethyl group is assigned the first priority and the nitro group is assigned the fourth priority. Otherwise, you could write it as 4 ethyl, 1 nitro benzene. 4 ethyl, 1 nitro benzene. This should be the exact name for this molecule. 4 ethyl is coming earlier because E comes earlier as compared to the alphabet N. So 4 ethyl 1 nitrobenzene should be the correct name for this. So this way we have discussed mono-substituted benzenes and the di-substituted benzenes. We are only left with poly-substituted benzene derivatives. How you would name poly-substituted benzene derivatives? In this case, we are going to discuss two subcases, subcase number A and subcase number B. So let's take the first subcase. In this case, you are going to assign one functional group as the main functional group and the two of the substituent are going to be used as prefix. So here benzene with COH is going to be named as benzoic acid. So whenever you give a unique name to something, you are always going to give it the number 1. And later on you move to assign numbers to the other alphabet. The numbering has happened through 1, 2, 3, 4. It is not like 1, 2, 3, 4. The hydroxy would get the same number, but the bromine will get 5 number if you come from here. So instead you decide that you should come through this way. 1, 2, 3, 4. So 3 bromo, 4 hydroxy benzoic acid. Bromine is earlier because B comes earlier in alphabet series and H comes later on. Let us take next example. In this case, you have benzene with CHO. So this can be called benzaldehyde. And you can assign the numbering. So numbering will go through 1, 2, 3, 4. So there is a methoxy over here and a hydroxy over here. So H comes earlier. So 4 hydroxy is gonna come earlier, then 3 methoxy, and collectively it is benzaldehyde. Let us take the last example. I know the lecture has gone longer, so just be patient. This is going to be the last subcase. After that, we will be able to completely finish the nomenclature and the classification of benzene and its derivatives. Whatever you have studied so far can be considered as the classification of benzene and its derivatives. Otherwise, you are definitely learning about the IUPAC nomenclature of benzene derivatives. Let us take the first example. In this case, there are two groups which are common. So this can become dinitrobenzene and this is chloro. So among C and D, C comes earlier. So first position to chloro because it has higher atomic number, and 2, 4 dinitrobenzene. And if you consider this case, there is ethyl, there is fluoro, and there is nitro. So E comes the earliest, the highest atomic number belongs to fluorine, so the number goes as 4 for ethyl. So 4 ethyl, then comes F, so 1 fluoro, then comes nitro, so 2 nitro benzene. Because there is no main functional group, you cannot assign any unique name to benzene ring. So this way we have discussed a very big topic, isn't it? We have discussed from very simple things to very complex things. I hope all the things were clear to you. This way we have completed nomenclature of benzene derivatives. In the next session, we are going to discuss the journey of discovery of benzene and the derivation of the structure of benzene, because it is the most important topic of this unit, that you must understand how much difficult it was to derive the structure of benzene. So we will start discussing such topics from the next lesson.